students, for today's lesson we are going to recall back about our infinite limit. So there are a few other examples about infinite limit. The first one, we look at the theorem 1. If limit x approaching a for function fx plus gx by theorem, we can split it up into limit x approaching a fx plus limit x approaching a gx. But we notice that if limit fx for x approaching a is equal to infinity, and also limit x approaching a for gx is equal to L, then we can substitute the value because we just split it up by theorem. So infinity plus L, the answer will be infinity. For example, if I give you limit x approaching 1 from right for function 1 over x minus 1 plus 2 over x plus 1, so we can solve it by using the theorem, split it up into 2, and then just solve the limit by using substitution. So for the first part, if I substitute 1 inside x, what I get is case 1 over 0. So the answer is just can be either it is positive infinity or negative infinity. So if I look at the top, the numerator will always be in positive sign. So if I take 1 from right, so I pick, let's say, x equals to 2 and substitute into the function. 2 minus 1 is equal to 1. So the denominator will also be positive. Hence, the answer is positive infinity. So limit x approaching 1 from right for function 2 over x plus 1, by using substitution, R will get 2 over 2 equal to 1. So we just add it up. Any positive infinity and that with any number, the answer would be positive infinity. Then we look at the second theorem. If limit x approaching a for fx is equal to infinity and limit x approaching a for function gx is equal to L when L cannot be 0, then if, let's say, your L is less than 0, so if I want to ask you to find limit x approaching a for two functions being multiplied, so let's say fx multiplied with gx, by theorem we can split it up into 2. So limit x approaching a fx multiplied by limit x approaching a gx. So we just need substitute it. By substitution, we have infinity multiplied by L. Remember that your L is negative, so any negative number multiplied with infinity, then the answer will be negative infinity. It will be the same for if the L value is positive. So let's say if I give to you limit x approaching a for function fx is equal to infinity and limit x approaching a for function gx is equal to L, then L cannot be 0. So let's say if L is greater than 0, which is L is positive, so by theorem I want you to find limit x approaching a fx multiplied by gx. So by theorem we can split it into 2. So by substitution we'll get infinity multiplied by L, but remember your L is positive, hence the answer will be positive infinity. How about if when negative infinity multiplied by L when L is positive, or negative infinity multiplied by L when L is negative? So then we look at this example. So I want you to find the limit for the function below. So limit x approaching 1 from left for function 4x over x squared minus 4x plus 3. So then we can solve it by theorem. We can split it up. So you'll get limit x approaching 1 from left 4 multiplied by limit x approaching 1 from left for function 1 over x minus 3 multiplied by limit x approaching 1 from left for function 1 over x minus 1. So you just need to do the substitution. So I substitute 1 into 4x, I got 4. I substitute 1 into 1 over x minus 3, I get negative 1 over 2. But when I try to substitute 1 into function 1 over x minus 1, I get case 1 over 0. So the answer would be either positive infinity or negative infinity. So we need to check. Limit a constant will be the constant. So 1 is always positive. Okay, and then for the denominator, okay, I want 1 from left, so I pick any number from left one. So let's say I pick x is equal to 0. So substitute inside the function 0 minus 1, I get negative 1. Hence, the denominator sign will be minus. Positive divide by negative, the answer will be negative infinity. So check, I get the number is negative infinity. So I just need to multiply everything. Positive times negative times negative. So I'll get positive infinity as the answer. For the next lesson, we're going to learn about limit at infinity. The symbol infinity does not represent a real number. It's a notation used to denote how certain function behave. So infinity knows no bound, no end, just continuous. The limit of fx as x approach infinity is the limit of f as x moves increasingly far to the right to the number line. The limit of x as x approach negative infinity means the limit of f as x moves increasingly far to the left of the number line. If a function f approaches L as x increase without limit, then we can write it as limit x approaching positive infinity for function fx is equal to L. If a function f approaches m as x decreases without limit, then we can write it as limit x approaching negative infinity for function fx is equal to m. The theorem of limits at infinity that we need to know is for n greater than 0, which means n is positive integer. The first one is, if limit x approaching positive infinity for function 1 over x to the power of n, if we substitute infinity inside the function, okay, you will get 1 over infinity. If you get any 1 over infinity, the answer would be 0. And another one, if limit x approaching negative infinity for the same function 1 over x to the power of n, okay, we substitute negative infinity inside the function, you get 1 over negative infinity. The same goes for it, the answer would be 0. So for instance, if I give you limit x approaching positive infinity for function 2 over x minus 1, we can split it into by using theorem. So we'll get limit x approaching positive infinity for 2 multiplied by limit x approaching positive infinity for function 1 over x minus 1. So limit x approaching positive infinity for a constant, the answer would be the same constant. But for this part, you get, if you substitute infinity inside, you get 1 over infinity. So it will be 0. 2 times 0 will be 0. How about if you have limit at infinity for rational function? So for rational function, for instance, if you have limit x approaching infinity for function fx divided by tx, if you substitute the function the value infinity inside the function, you'll get case infinity over infinity. If you have this kind of solution, infinity over infinity, you cannot solve it or let the answer just like that. You need to divide the numerator and denominator with xn, where n is the highest power of x in the denominator. Remember back the definition of set x squared, which is equal to modulus x. So where modulus x is equal to x, if x is greater than 0 or x approaches positive infinity. And another one is modulus x can be written as negative infinity if x approaching negative infinity or x is less than 0. Alright, so in order to solve limit to infinity, okay, in your tutorial question, let me look at question number 12. Question number 12, part F. So they give to you limit x approaching infinity for function 6 minus 5x divided by x squared plus 2x plus 1. So if we try by substitution, you will get 6 minus 5 times infinity over infinity squared plus 2 infinity plus 1. So you get case infinity, negative infinity over infinity. So negative infinity over infinity, you cannot solve it just like that or leave it the answer like that. What should you do is you need to multiply both numerator and denominator by the highest xn from the denominator. So here the highest xn is x squared, so we need to divide both numerator and denominator by x squared. So you get limit x approaching infinity, 6 minus 5x divide by x squared, divide everything by x squared plus 2x plus 1, also divided by x squared. Okay, and then what should you do is just you need to simplify the function. So for you not to make mistake, just distribute it evenly. 6 over x squared minus 5x over x squared. So this is for the numerator. For the denominator, you will get x squared over x squared plus 2x over x squared plus 1 over x squared. So next, what should you do is just you need to simplify this one. So you get limit x approaching infinity. For the numerator, you will get 6 over x squared minus 5 over x. Okay, and then for the denominator, you get 1 plus 2 over x plus 1 over x squared. Okay, so after that, what should you do is you just need to substitute the infinity inside the function. So you get 6 over infinity squared minus 5 over infinity divided by 1 plus 2 over infinity plus 1 over infinity squared. So 6 over infinity is 0 minus 0 over 1 plus 0 plus 0. Hence the answer 0 over 1 would be 0.